and TFG is going to come out to be positive 4L. Now that I know the forces in those three members, now I can cut a section across this way, which would cut through the member that I want. Because I already know ED, I already know DF, the only two new forces that would come in would be DG and GH. But I can do it even easier than that. Just because I chose to use method of sections once doesn't mean that that's the only thing that I can do. Instead, I think what I would like to do is I would like to draw a free body diagram of joint D. Again, just because I divided it into two big chunks to use method of sections first doesn't mean I can't change my mind to do method of joints a little bit later on. And the method of joints, all forces act through a point. None of the forces have moments about the point, so I don't have to worry about moment equilibrium. It's usually a simpler method than the method of sections if it gets the same thing. So looking at joint D, I'm going to have a force in DG, I'm going to have a force in FG, and I already have a value for the force in FG, it's positive 4L, and I'm going to have a force in member GH. Is DG a zero force member? It acts at an angle to the FG, but FG and GH aren't collinear. They're not along the same line. If these were along the same line, the sum of forces in the y direction would give TDG was equal to 0. But because this is at an angle, the sum of forces in the vertical direction will not give TDG equal to 0. If you're unsure, draw the joint and write the equations. Yes?
Is this joint G or D?
Joint G, isn't it? Looks kind of funny for joint D. D has 5 members attached to it. G only has 3. So yeah, it should be member G, or joint D, G. I'll call this angle phi, and writing the equations, summing forces horizontally, I'm going to get TGH cosine of phi minus TFG equals 0, and TDG minus TGH sine of phi equals 0. Where TFG is equal to plus 4L. So the first equation I can solve for TGH. Well, first I've got to figure out what phi is. And if we look at the line from G to H, which makes the angle phi with the horizontal, G is 1 foot above H, and it's 4 feet away from H. So the tangent of phi is 1 over 4, and phi is equal to 14.0362 degrees. Okay, so again, now we can solve for TGH. This is going to give TGH is equal to 4.12311L. And when I put that into the second equation, I can solve for TDG, which is what I'm ultimately interested in. And it comes out to exactly 1L. Positive, which means tension, as was drawn. So that's probably not going to be the one that's going to break. I mean, Here's one that has a tension of 4L. Here's one that has compression of 3L. So those are a lot more likely to break than the DG. But again, I was probably just trying to check my computer program and make sure that I entered the data in correctly and it was giving me results that were correct. If this one's verified, then I'll believe the rest of them that the computer gives me. So in the method of sections, we divide the structure into 2 chunks, hopefully cutting through no more than 3 members, and hopefully one of them will be the member that we're interested in, the one whose force we're trying to find. But we still typically have to do overall equilibrium first to find the support reactions, so when we divide it into chunks, we have something that we can solve. So in this case, we're trying to find the forces in members BC, CD, and CG. And all of these triangles are equilateral triangles. So we have 1, 2, 3, 4, and we have another one over that side. We're going to have supports JX, JY. The rope up here can provide only a vertical force, DY. We have a load applied here, which is 3 kilonewtons. And we have a load applied perpendicular to the member of 5 kilonewtons. Now, if these are all equilateral triangles, then this is going to be 60 degrees. That's a right angle, so that's going to be 30 degrees out there for that 5 kilonewton force. And A, B, C, D, E, F, G, H, I, and J. I want to know the forces in members BC, CD, and CG. Well, there is no section that cuts through all 3 of those, but what I can do is I can cut a section through 3 members here, and then once I know those 2, I can use the method of joints at that joint to find the other one that I'm interested in. So those are the kinds of things that you look for. First off, we have to do overall equilibrium, because whichever side we choose, we're going to have to use a support. This side has a support, that side has a support. I've got to find the supports of whichever side I'm going to keep. First thing I might do is calculate the height of that equilateral triangle. This is going to be 8, 4, 4, 8,